Early December, 1941. A roadside ambush site, 20 kilometers south of Tobruk, Libya. The disabled American truck sat motionless in the desert sand, its crew having abandoned it during a hasty British withdrawal. Standard Afrika Korps procedure dictated destroying enemy vehicles or stripping them for parts before moving on. But Hauptmann Friedrich Weber had different orders that morning. His reconnaissance battalion commander wanted every captured Allied vehicle examined before destruction. Intelligence needed data on American equipment now flooding into North Africa through British Lend-Lease channels. Weber approached the small vehicle with professional skepticism. It looked absurdly compact compared to the Kübelwagen parked beside it. The American machine measured barely 11 feet in length, stood just over 4 feet high, and appeared almost comically narrow. The placard on the dash identified it as a Willys MB. The Americans called it a Jeep. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Weber had commanded mechanized reconnaissance units since the invasion of Poland. He understood light vehicles. The Kübelwagen, designed by Ferdinand Porsche and based on the Volkswagen Beetle, had served the Wehrmacht admirably across multiple theaters. Its air-cooled engine proved reliable in desert conditions where liquid-cooled motors overheated. Its lightweight construction allowed it to float across soft sand. Its simple maintenance requirements meant that even minimally trained mechanics could keep it operational. This American vehicle looked crude by comparison. Heavier. More complex. The welded steel body panels appeared hastily, stamped rather than carefully formed. The design seemed utilitarian to the point of ugliness, lacking the Kübelwagen's streamlined efficiency. But then Weber noticed the transfer case. A single lever protruding from the transmission tunnel, clearly labelled with positions marked in English, 2H, 4H, 4L, neutral. He had seen enough military vehicles to recognize what this meant. Four-wheel drive. Not just rear-wheel propulsion like the Kübelwagen, but power delivered to all four wheels whenever the driver chose. He called for his senior mechanic, Unteroffizier Klaus Hartmann, who had maintained everything from motorcycles to half-tracks during 3 years of campaigning. The mechanic arrived and immediately began his examination, opening the hood to inspect the engine compartment. What Hartmann discovered in the next hour would challenge assumptions that had guided German military vehicle design since the mid-1930s. The revelation came not as a dramatic moment, but as a gradual understanding that accumulated with each detail he examined. The Go Devil engine displaced 134 cubic inches and produced 60 horsepower at 4,000 RPM. Not remarkable by German standards, where the Kübelwagen's later 1.131-litre engine generated 25 horsepower from just over half the displacement. But the American engine's design philosophy reflected something fundamentally different from German engineering practice. This power plant wasn't built to achieve maximum efficiency or optimal performance characteristics. It was built to be manufacturable in enormous quantities, maintainable by minimally trained personnel, and reliable under conditions that would destroy more sophisticated motors. Every component appeared designed for rapid replacement rather than careful adjustment. The carburetor used simple settings that required no delicate tuning. The ignition system employed conventional points and condensers that any mechanic could service with basic tools. The oil filter could be changed without draining the crankcase. German military engines, by contrast, demanded constant attention from trained specialists. The turret, Kübelwagen's air-cooled motor, required careful valve adjustment to maintain proper clearances. Its magneto-ignition system needed precise timing. Its oil system demanded specific grades of lubricant matched to ambient temperatures. Hartmann moved to the transmission. The Americans had installed a synchronized gearbox with 5 forward speeds and 1 reverse. Synchronization in 2nd through 5th gear meant drivers could shift without double clutching, a technique that required weeks of practice to master in German vehicles. The Americans had apparently designed this transmission expecting that ordinary soldiers with minimal training would operate it under combat stress. But the transfer case revealed the most significant difference. The four-wheel drive system engaged through a simple mechanical linkage. a single lever operation. The Kübelwagen, lacking four-wheel drive entirely, required skilled driving technique to navigate difficult terrain. Experienced drivers learned to use momentum and careful throttle control to traverse soft sand or steep slopes. The Jeep simply powered through obstacles, using traction from all four wheels. Hartmann completed his initial inspection and reported to Weber. Herr Hauptmann, this vehicle represents a completely different design philosophy from our Kübelwagen. The Americans have sacrificed sophistication for simplicity. They've chosen manufacturability over engineering elegance. But for field operations under combat conditions, their approach may prove more effective than ours. Weber frowned. German engineering superiority had been a cornerstone of Wehrmacht confidence since the war's beginning. German tanks mounted better guns and heavier armor than Allied equivalents. German aircraft employed more advanced aerodynamics and weapon systems. German small arms demonstrated superior ergonomics and accuracy. The notion that American engineers might have developed a superior military vehicle seemed unlikely, almost inconceivable. "Test it," Weber ordered. "Drive it across terrain where our Kübelwagen struggles. Determine its actual capabilities, not its theoretical specifications." What followed over the next 3 days would force Weber and his battalion to confront uncomfortable truths about German vehicle design choices and American industrial capabilities. The implications would extend far beyond a single captured truck. They would reveal fundamental differences between German and American approaches to mechanized warfare, differences that would prove decisive as the conflict escalated. By early December 1941, the strategic situation in North Africa had grown increasingly complex. British forces, reinforced by Commonwealth troops from Australia, New Zealand, India, and South Africa, had launched Operation Crusader in November to relieve the besieged garrison at Tobruk. The Afrika Korps under General Erwin Rommel found itself engaged in a brutal mobile campaign across hundreds of kilometers of desert terrain. Logistics determined survival in this environment more certainly than tactical brilliance. Vehicles that broke down left their crews stranded in hostile territory. Mechanical failures could prove as fatal as enemy action. The ability to maintain mobility under harsh conditions separated effective units from those that ceased to function as combat-capable formations. The Wehrmacht had entered World War II with confidence in its vehicle standardization program. From 1933 through 1938, German industry had developed the Einheits-PKW der Wehrmacht, standardized military vehicles designed to provide the armed forces with reliable light transports. This program produced tens of thousands of vehicles built to common specifications, all air-cooled to eliminate radiator vulnerabilities, all designed for ease of production. The Kübelwagen represented the second generation of this philosophy. Developed from 1938 onward, it improved on earlier designs by reducing weight, simplifying construction, and increasing reliability. Ferdinand Porsche had applied lessons from the Volkswagen Beetle program to create a military vehicle that embodied German engineering principles: precision manufacturing, efficient materials usage, sophisticated technical solutions. The Type 82 Kübelwagen measured 3.74 meters in length and weighed approximately 700 kilograms empty. Its flat-four air-cooled engine provided adequate power for a vehicle designed primarily for reconnaissance and liaison duties. Portal reduction gear hubs in the rear axle increased ground clearance and improved torque delivery. Its flat underbody allowed it to slide across soft sand or snow when traction failed, essentially functioning as a motorized sled in extreme conditions. German commanders appreciated the Kübelwagen's virtues. It consumed less fuel than heavier vehicles. Its air-cooled engine eliminated radiator freeze damage in Russian winters and overheating problems in desert heat. Its lightweight construction meant that soldiers could physically push or lift it free when stuck. Its simple mechanical systems reduced maintenance requirements compared to more complex designs. But the Kübelwagen had one critical limitation that German engineers had consciously accepted as a necessary trade-off. It was rear-wheel drive only. Four-wheel drive systems added weight, complexity, and production cost. German designers had concluded that these disadvantages outweighed the benefits of improved traction. They believed that skilled driving technique and clever engineering of the suspension and reduction hubs could compensate for the lack of power to the front wheels. This design philosophy made sense in peacetime conditions or limited tactical scenarios. But in total war, fought across multiple theaters with varying terrain, the Kübelwagen's lack of four-wheel drive proved increasingly problematic. In the soft sand of North Africa, rear-wheel drive vehicles frequently became stuck, requiring time-consuming recovery operations. In the mud of Russia during autumn rains, Kübelwagens struggled where tracked vehicles or four-wheel drive trucks maintained mobility. In mountainous terrain like Italy, slopes that four-wheel drive vehicles could ascend proved impassable to rear-wheel drive transports. American engineers had made different choices when designing their military light vehicle. In July 1940, the U.S. Army Quartermaster Corps issued specifications for a quarter-ton, four-wheel drive reconnaissance car. The requirements emphasized practical utility over engineering sophistication. The vehicle needed to carry 3 men plus equipment, traverse rough terrain, operate reliably under field conditions, and remain simple enough that minimally trained personnel could maintain it. 3 American companies responded to the specifications: American Bantam Car Company, Willys Overland Motors, and Ford Motor Company. Each submitted prototypes during the competitive testing phase. In 1940 and early 1941, Bantam produced the first working prototype in just 49 days. Willys contributed the powerful Go Devil engine that provided superior performance. Ford offered manufacturing expertise and production capacity. By July 1941, the War Department selected the Willys design as the standard model, designated the Willys MB. The selection criteria emphasized the Go Devil engine's power output, the vehicle's low silhouette, and Willys' competitive bid of $748.74 per unit. Ford received contracts to produce identical vehicles under license, designated the Ford GPW, with the W indicating Willys' licensed design. The resulting vehicle embodied American automotive engineering philosophy developed through decades of civilian mass production experience. The United States had become the world's most highly motorized nation during the 1920s and 30s. Widespread automobile ownership meant that millions of Americans understood basic vehicle operation and maintenance. The domestic auto industry had perfected mass production techniques pioneered by Henry Ford, creating manufacturing systems capable of producing vehicles by the millions while maintaining acceptable quality standards. American military vehicle designers applied these civilian industry lessons to the Jeep. They specified components proven in commercial service rather than developing new proprietary systems. They designed for manufacturability first, accepting minor performance compromises in exchange for massive gains in production speed. They standardized every component so that parts from different manufacturers and production batches would be perfectly interchangeable without adjustment. The four-wheel drive system represented the most significant difference from German design philosophy. American engineers concluded that the advantages of power delivered to all 4 wheels justified the added weight and complexity. The transfer case added perhaps 45 kilograms to the vehicle's weight and required an additional lever in the cab, but it transformed the Jeep's cross-country mobility in ways that no amount of clever suspension engineering could match. Unteroffizier Hartmann spent the first test day driving the captured Jeep across progressively more difficult terrain near the battalion's forward position. He began with firm desert surface, then moved to areas of soft sand where Kübelwagens typically struggled. The contrast in performance proved immediately apparent. On firm ground, both vehicles performed adequately, though the Jeep's extra power provided brisker acceleration. But when Hartmann entered soft sand, the differences became dramatic. In rear-wheel drive mode, the Jeep behaved much like a Kübelwagen, requiring momentum and careful throttle control. But when Hartmann engaged four-wheel drive, the vehicle's character transformed entirely. With power delivered to all 4 wheels, the Jeep simply powered through sand that would have bogged a Kübelwagen. The front wheels pulled while the rear wheels pushed, distributing traction demands across 4 contact patches instead of 2. The low-range gearing provided enough torque to crawl over obstacles at walking speed without stalling the engine. Hartmann tested increasingly severe conditions. Steep ascents up dune faces that Kübelwagens could only climb with perfect momentum became routine for the Jeep in four-wheel low range. Soft sand pockets that trapped rear-wheel drive vehicles proved merely annoying rather than mission-ending to the four-wheel drive Jeep. Rocky terrain, where careful wheel placement determined whether a Kübelwagen could proceed, became straightforward for the Jeep's superior traction. By the end of the first test day, Hartmann had reached conclusions he reported to Weber with careful objectivity. The American vehicle outperforms our Kübelwagen in difficult terrain by a significant margin. The four-wheel drive provides advantages we cannot match through driving technique alone. An average driver in the American vehicle can traverse obstacles that would require an expert driver in our Kübelwagen, and some terrains simply cannot be crossed by rear-wheel drive vehicles regardless of driver skill. Weber absorbed this assessment with growing unease. If the Americans could produce four-wheel drive vehicles in quantity while Germany relied on rear-wheel drive transports, the implications for mechanized warfare were troubling. But perhaps this was an isolated prototype, an experimental vehicle not representative of American production capabilities. How many of these vehicles do the Americans plan to manufacture? Weber asked. Hartmann had found maintenance documentation in the Jeep's glove compartment. The papers indicated a serial number in the 6,000s, suggesting thousands of units already produced by spring 1941. But more troubling were references to production contracts calling for delivery of hundreds of thousands of vehicles. The documents suggest very large-scale production, Herr Hauptmann, possibly hundreds of thousands of units. Hundreds of thousands. The number seemed impossible. Germany had produced approximately 50,000 Kübelwagens total since 1940. American factories appeared capable of producing 10 times that number of superior four-wheel drive vehicles. The implications extended beyond simple vehicle counts. If America could manufacture light utility vehicles in such quantities, what did that suggest about American industrial capacity for producing tanks, trucks, aircraft, and all the other material necessary for modern mechanized warfare? And if American vehicles proved superior in design to German equivalents, what did that reveal about assumptions of German engineering supremacy? These questions would grow more urgent as additional intelligence reached Africa Corps headquarters through late 1941 and early 1942. Reports from multiple units documented captured Jeeps. Every assessment praised the vehicle's reliability and four-wheel drive capability. Wehrmacht mechanics who examined captured Jeeps uniformly concluded that the American design philosophy prioritized practical effectiveness over engineering sophistication, and that this approach produced superior results under field conditions. By February 1942, certain patterns had emerged clearly enough that German technical intelligence services could no longer dismiss them as anomalies. The Americans were producing military vehicles in quantities that dwarfed German output. American vehicles employed design principles fundamentally different from German practice, prioritizing manufacturability and field reliability over technical sophistication. And American vehicles appeared to perform better than their German counterparts in sustained combat operations, despite being less impressive in specification sheets. The Jeep became the symbol of these disturbing revelations, not because it was the only example, but because it was the most visible. Every front where Wehrmacht forces engaged American or British troops equipped through Lend-Lease saw Jeeps in action. Every captured Jeep that German mechanics examined reinforced the same lessons about American industrial capacity and design philosophy. Hauptmann Weber's battalion continued using the captured Jeep for reconnaissance operations through early 1942. The vehicle proved so reliable and capable that it became preferred transport for forward observers and liaison duties. When parts wore out, replacement components were scavenged from other captured Jeeps with remarkable ease. Everything was interchangeable, just as American design philosophy intended. In March 1942, Weber prepared a detailed report for submission to division headquarters. He documented the Jeep's superior performance in soft sand, steep terrain, and rocky ground. He noted its simple maintenance requirements that allowed any minimally trained mechanic to service it. He emphasized the implications of American four-wheel drive production capacity for future operations. The report concluded with observations that challenged fundamental assumptions Weber had held since joining the Wehrmacht. The American Jeep represents a design philosophy that prioritizes practical effectiveness over engineering elegance. German vehicles demonstrate superior sophistication in individual components, but American vehicles achieve superior operational performance through intelligent application of simple, proven technology combined with manufacturing excellence. In sustained combat operations, the American approach proves more effective than our emphasis on technical sophistication. This assessment, multiplied across hundreds of similar reports from units on all fronts, would force German military leadership to confront uncomfortable truths about industrial warfare in the 20th century. Technical sophistication mattered less than mass production capability. Engineering elegance meant nothing if vehicles broke down before reaching combat. The side that could field more reliable vehicles in greater numbers would dominate the battlefield, regardless of which side built the most impressively engineered individual machines. The Jeep had taught this lesson clearly to anyone willing to learn. By 1942, German officers and mechanics who had examined captured Jeeps understood these truths. Whether that understanding would influence German vehicle design and production remained uncertain, but the knowledge itself could not be unlearned once acquired. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. By summer 1942, the mathematics of Jeep production had become impossible for German intelligence to ignore. Reports from captured documents, interrogations of Allied prisoners, and observations by agents in neutral countries all pointed to the same staggering conclusion. American factories were producing military vehicles at rates that exceeded the entire output of German industry by factors of 10 or more. The Ford Willow Run plant in Michigan, dedicated to bomber production, completed a B-24 Liberator every 63 minutes at peak capacity. The Willys Overland facility in Toledo, Ohio, and Ford's parallel production line churned out Jeeps at similar rates. By the end of 1942, American factories had delivered over 177,000 quarter-ton trucks to military service. Production was still accelerating. German industrial planners studied these figures with mounting alarm. The Kübelwagen production facility in Wolfsburg operated at maximum capacity but could deliver perhaps 15,000 vehicles annually under optimal conditions. Strategic bombing was not yet affecting German production significantly in 1942, yet Germany's maximum peacetime industrial capacity could not approach American wartime output. Wehrmacht officers in North Africa witnessed the implications directly. British and Commonwealth forces, equipped through American Lend-Lease programs, fielded Jeeps in quantities that seemed inexhaustible. When Allied units retreated, they often abandoned damaged vehicles rather than attempting recovery because replacement Jeeps would arrive within days. German units, by contrast, invested enormous effort recovering every disabled Kübelwagen because replacement vehicles took weeks or months to obtain. Oberst Heinrich Müller commanded a panzer regiment during the battles around El Alamein in late 1942. His after-action reports documented the psychological impact of Allied material abundance on German troops. "Our soldiers fight with courage and skill," Müller wrote, "but they witness enemy supply columns that stretch to the horizon. They see Allied vehicles abandoned after minor damage because the enemy possesses such abundance that repair is unnecessary. This creates a sense that we fight not just an army, but an entire industrial civilization whose productive capacity we cannot match." The Jeep symbolized this disparity more vividly than larger equipment. Tanks and artillery pieces were complex weapons that required specialized production facilities. But the Jeep was fundamentally a simple vehicle, not dramatically different from civilian automobiles. If Americans could produce Jeeps by the hundreds of thousands, what did that suggest about their capacity to manufacture everything else warfare demanded? By November 1942, German technical intelligence had compiled comprehensive data on American Jeep production and capabilities. The analysis revealed patterns that contradicted German pre-war assumptions about American industry and engineering competence. The United States had produced approximately 180,000 quarter-ton trucks during 1942 alone. This single year's production exceeded total German Kübelwagen output from 1940 through 1945. American factories achieved this output while simultaneously producing millions of other military vehicles, including 2.5-ton trucks, tank transporters, amphibious craft, and armored vehicles. More troubling than the raw numbers was the consistency of quality. German intelligence officers interviewed mechanics who had examined dozens of captured Jeeps. Every report emphasized the remarkable uniformity of components across different production batches and manufacturers. A part manufactured by Willys in January 1942 would fit perfectly into a Ford-built vehicle from September 1942 without any adjustment or modification. This level of standardization proved alien to German manufacturing practice. German military vehicles from different manufacturers required unique parts and distinct maintenance procedures. Even vehicles from the same manufacturer at different production periods often featured modifications that prevented component interchangeability. German logistics officers struggled constantly with spare parts inventory management because the Wehrmacht operated dozens of different vehicle types with incompatible components. American standardization eliminated this complexity. Every Jeep used identical engines, transmissions, axles, electrical systems, and running gear. A mechanic trained on one Jeep could service any other Jeep without additional instruction. Parts depots needed to stock only one set of components to support the entire fleet. Field repair became dramatically simpler, because any damaged vehicle could be cannibalized to provide parts for others. The strategic implications extended beyond logistics. Standardized production allowed American industry to employ semi-skilled workers who could master simple, repetitive tasks, rather than requiring the highly trained craftsmen German production depended upon. As American men entered military service, women and workers with minimal industrial experience filled factory positions without significantly impacting production quality or speed. Germany lacked both the industrial philosophy and the workforce depth to replicate American methods. German manufacturing tradition emphasized craftsmanship and precision. Skilled workers spent years learning their trades through apprenticeship programs. This approach produced excellent results in peacetime but could not scale to meet total war demands when skilled workers were conscripted for military service. The four-wheel drive advantage that had impressed Hauptmann Weber in North Africa proved decisive across every theatre where terrain challenged vehicle mobility. In the mountains of Italy, Jeeps climbed trails that left Kübelwagens stranded. In the Bocage country of Normandy, Jeeps powered through mud-choked lanes, while German vehicles required careful navigation or became hopelessly mired. On Pacific Islands, Jeeps traversed volcanic sand and jungle tracks that defeated two-wheel drive vehicles. German commanders who captured and used Jeeps filed reports praising their capabilities with remarkable consistency. The tone of these assessments shifted from initial skepticism to grudging respect to outright admiration as officers gained experience with American vehicles under combat conditions. A captured document from a Wehrmacht reconnaissance battalion operating in Italy during 1943 stated, "American Jeep vehicles demonstrate superior mobility in mountainous terrain compared to our Kübelwagen. The four-wheel drive provides traction advantages that cannot be overcome through driving skill alone. Vehicle reliability exceeds our expectations. We have operated captured Jeeps for 3 months without significant mechanical failures. Recommend priority effort to capture additional Jeep vehicles for reconnaissance duties." Similar reports flooded into Wehrmacht headquarters from every front. The 10th SS Panzer Division captured 12 M4A3 Sherman tanks and multiple Jeeps during Operation Nordwind in January 1945. The Jeeps were immediately pressed into service with reconnaissance units. German crews preferred them to Kübelwagens for their reliability and four-wheel drive capability. Soviet forces received over 51,000 Jeeps through the Lend-Lease program. Red Army officers praised the vehicles enthusiastically. Soviet automotive industry had produced the Gaz 67, a light utility vehicle influenced by the American design, but in quantities insufficient to meet Red Army needs. American Jeeps filled the gap, providing Soviet reconnaissance and liaison units with mobility that German two-wheel drive vehicles could not match. By 1943, the cumulative weight of evidence forced even skeptical German officers to acknowledge American vehicle superiority in practical terms. The Kübelwagen remained an excellent vehicle for its design parameters. But those parameters had been set based on assumptions about the nature of modern warfare that American experience proved incomplete. German designers had assumed that lightweight vehicles would suffice for reconnaissance and liaison duties, with heavier trucks handling supply transport. They had assumed that skilled drivers could compensate for two-wheel drive limitations through careful technique. They had assumed that air-cooled engines provided advantages sufficient to outweigh any benefits of water cooling. They had assumed that sophisticated engineering would triumph over simple brute force solutions. American designers had made different assumptions rooted in different experiences. They assumed that vehicles would be operated by minimally trained personnel under maximum stress. They assumed that field conditions would destroy sophisticated systems faster than simple ones. They assumed that abundant spare parts mattered more than extended component life. They assumed that quantity had a quality all its own. The production numbers told the story most starkly. By the war's end, American and Ford factories would deliver 647,345 quarter-ton trucks to military service. This represented 12 times the total Kübelwagen production, despite the Jeep being heavier, more complex, and more capable than the German vehicle. Oberst Müller encountered these statistics in an intelligence briefing during early 1944. His response, recorded in his personal diary, captured the sense of futility that pervaded German officer corps by that stage of the war. We have been taught since childhood that German engineering leads the world. Our vehicles, our weapons, our industrial methods represent the pinnacle of modern development. Yet we face an enemy who produces adequate equipment in quantities that render our sophistication irrelevant. 1,000 superior German tanks matter less than 10,000 adequate American tanks. Quality becomes meaningless when overwhelmed by quantity. The psychological impact on German forces extended beyond mere numbers. Soldiers who witnessed the material abundance of Allied forces understood that Germany faced opponents whose industrial capacity made victory impossible, regardless of tactical skill or strategic brilliance. The Jeep became the visible symbol of this disparity because it appeared everywhere, seemingly inexhaustible, utterly reliable, and superior in capability to German equivalents. Wehrmacht mechanics, who maintained both German and captured American vehicles, reached similar conclusions through direct experience. Unteroffizier Hartmann, who had conducted the first evaluation of Weber's captured Jeep, continued working with American equipment through 1943. His maintenance logs documented stark differences in reliability between German and American vehicles. Kübelwagens required valve adjustments every 1,000 kilometers. Jeeps needed no valve service for their entire operational life. Kübelwagens demanded frequent generator and magneto maintenance. Jeeps featured conventional electrical systems that rarely failed. Kübelwagens suffered transmission problems when drivers shifted improperly. Jeeps' synchronized transmissions forgave operator errors that would damage German gearboxes. The cumulative effect of these differences appeared in readiness rates. Units equipped with Kübelwagens typically maintained 70 to 80% operational readiness under good conditions, dropping lower during extended operations. Units using captured Jeeps consistently achieved 90% or higher readiness with minimal maintenance effort. By 1944, some German units actively sought to capture Jeeps rather than destroy them. The vehicles had become more valuable to Wehrmacht logistics than enemy equipment deserved to be. This represented a fundamental inversion of normal capture priorities, where enemy equipment was destroyed to deny it to opponents. American production continued accelerating through 1944, despite Germany's desperate hope that Allied industrial capacity would peak and decline. The statistics grew more crushing with each quarterly report. 1944 saw 182,000 Jeeps delivered to military service, maintaining the pace from previous years despite strategic bombing campaigns against German industry that forced production declines across every category of German military equipment. The contrast became impossible to rationalize through appeals to American industrial advantages in raw materials or geographic security from bombing. Even accounting for these factors, American output per factory worker exceeded German productivity by margins that suggested fundamental differences in manufacturing philosophy and practice. German industrialists who examined captured American equipment reached uncomfortable conclusions about their own methods. A report prepared by engineers from Daimler-Benz after studying a captured Jeep noted, American vehicle design prioritizes manufacturing efficiency over component optimization. Engine performance is modest but adequate. Transmission design is simple but effective. Suspension provides acceptable ride quality without sophisticated engineering. Yet the overall vehicle performs its missions more reliably than our equivalents, because every component is designed to be manufactured quickly and maintained easily. We have pursued perfection in individual elements, while Americans have optimized the entire system for mass production and field service. This insight arrived too late to influence German production during wartime. The Kübelwagen production lines could not be retooled to produce four-wheel drive vehicles without halting output for months. German automotive industry lacked the surplus capacity to develop and manufacture a Jeep equivalent while maintaining existing production commitments. And even if Germany could design and build a superior light vehicle, the strategic situation by 1944 made such efforts futile, given Allied air superiority and collapsing logistics. The Ardennes offensive in December 1944 provided final confirmation of American material superiority to German soldiers who still doubted it. German forces launched their last major Western offensive on December 16, attacking through the Ardennes forest, with objectives including the capture of Allied fuel depots. The German plan depended heavily on captured American supplies because Wehrmacht logistics could not sustain armored operations at the necessary scale. Among the equipment German planners most wanted to capture were Jeeps. Otto Skorzény's 150th Panzer Brigade, formed for infiltration missions behind Allied lines, specifically requested captured American vehicles because German vehicles lacked the reliability for deep penetration operations. The brigade obtained only 2 Jeeps, and only one proved serviceable enough for actual use. This scarcity of available captured vehicles revealed how effectively American logistics functioned. Previous German offensives had captured substantial Allied equipment during the initial advance, but American supply discipline and rapid response prevented significant captures during the Ardennes fighting. Damaged American vehicles were recovered or destroyed before German forces could seize them. This efficiency reflected systematic logistics planning that German forces increasingly lacked. The Ardennes, offensive ground to a halt by early January 1945, defeated partly by determined Allied resistance, but primarily by logistical collapse. German armoured divisions ran out of fuel and abandoned their tanks. Infantry divisions resorted to horse-drawn transport because motorized logistics had ceased functioning. American forces, by contrast, maintained continuous supply despite difficult winter conditions because their logistics system functioned with industrial efficiency. Jeeps played supporting roles in this Allied success. They transported forward observers who directed devastating artillery fire on German positions. They moved supplies forward to advancing units. They evacuated wounded soldiers to aid stations. They carried commanders conducting battlefield reconnaissance. They towed light artillery pieces into firing positions. They performed dozens of essential tasks that kept Allied forces operationally effective. German forces lacked equivalent capabilities because Kübelwagen production had never approached the scale necessary to motorize logistics at lower organizational levels. Wehrmacht divisions still relied substantially on horse-drawn transport for last-mile supply delivery. This limitation reduced operational tempo and prevented the kind of sustained offensive operations that American mechanization enabled. By spring 1945, the war in Europe approached its conclusion. Germany faced Soviet forces advancing from the east and American and British armies driving from the west. The strategic situation had become hopeless. Yet German soldiers continued fighting with the skill and determination that had characterized Wehrmacht performance throughout the war. In these final months, some German units still operated captured jeeps acquired during earlier campaigns. The vehicles continued functioning reliably despite years of service and minimal maintenance. This durability impressed German mechanics who had witnessed Kübelwagens require frequent repairs under similar conditions. A maintenance log from a Wehrmacht reconnaissance unit operating in the Ruhr pocket during April 1945 recorded, "American Jeep No. 3 continues operational after 18 months of service with our unit. Total maintenance required: 1 oil change, 1 set of spark plugs, 1 fuel filter. No mechanical failures. This vehicle has transported personnel through combat operations in Italy, France, and Germany without breakdown. Our Kübelwagens require substantially more maintenance and suffer frequent component failures under similar usage. American engineering philosophy proves superior to our traditional methods for military vehicle applications." This assessment, written weeks before Germany's surrender, captured lessons that would influence post-war German automotive industry fundamentally. The defeat had taught humility. American equipment had taught functional engineering. The combination would produce a new, German philosophy adapted to modern manufacturing realities. When Germany surrendered in May 1945, American forces occupied large portions of German territory. Military government units needed vehicles for occupation duties, and they hired German civilians as drivers and mechanics. Many of these German employees were former Wehrmacht personnel familiar with American equipment from wartime captures. Former Obergefreiter Hans Schmidt had maintained Kübelwagens and captured jeeps during 3 years of combat service. After his release from prisoner of war status in late 1945, he found work with the American military government's motor pool in Stuttgart. His supervisor, a U.S. Army captain, asked him to compare German and American vehicles based on his experience. Schmidt's response, delivered in halting English, summarized what thousands of German mechanics had learned. "The Kübelwagen is good vehicle for German methods. Lightweight, air-cooled engine, simple in some ways. But the Jeep is better vehicle for war. 4-wheel drive gives mobility we cannot match. American engine is reliable without constant adjustment. Transmission is easy to use. Everything is designed so any mechanic can fix it. American way is better for military use." This assessment reflected broader understanding, emerging within Germany's devastated industrial sector. The nation needed to rebuild not just factories but manufacturing philosophy. Pre-war emphasis on craftsmanship and precision remained valuable for certain applications, but modern mass production required different approaches. American methods offered models that German industry could adapt to European conditions. The Marshall Plan, announced in June 1947, provided capital for German industrial reconstruction. American advisors helped German manufacturers modernize their production methods, introducing assembly line techniques and standardization practices that German industry had resisted before the war. The results transformed German manufacturing capabilities while preserving traditional attention to quality. Volkswagen exemplified this synthesis of German and American approaches. The company had produced Kübelwagens during the war from its Wolfsburg facility. After the war, under British military supervision, Volkswagen resumed civilian Beetle production using improved manufacturing methods that incorporated American mass production principles. The Beetle's success validated the hybrid approach. It combined German attention to engineering detail with American emphasis on manufacturability and standardization. By the 1950s, Volkswagen exported Beetles globally, competing successfully in markets including the United States. The vehicle that had struggled as a military transport when limited to rear-wheel drive proved enormously successful as a civilian car, using similar mechanical principles improved through better manufacturing methods. Former Wehrmacht mechanics played significant roles in this industrial transformation. They understood both German traditional methods and American practical approaches from direct wartime experience. Their insights helped bridge the philosophical gap between pre-war German and American manufacturing cultures. Schmidt worked for the U.S. military government through 1948, then found employment with Daimler-Benz as a production supervisor. He helped implement assembly line improvements that increased output while maintaining Mercedes-Benz quality standards. His experience with American vehicles informed his understanding of how German manufacturers could increase efficiency without sacrificing the precision that German customers valued. By the 1950s, West German automotive industry had completed its transformation. Companies like Volkswagen, Mercedes-Benz, and BMW produced vehicles that combined German engineering reputation with manufacturing efficiency learned, partly through studying American methods. German exports grew rapidly, establishing the Made in Germany label as a global quality standard. This success, built on lessons from defeat, the Jeep had been among the teachers, not through any single dramatic revelation, but through cumulative evidence that American design philosophy worked better for practical applications than German emphasis on theoretical perfection. The production numbers remained the most compelling evidence. 647,345 Jeeps delivered during World War II, compared to approximately 50,000 Kübelwagens. This 12-to-1 ratio represented not just industrial capacity, but fundamental differences in how the two nations approached manufacturing challenges. American industry had developed mass production expertise through decades of civilian automotive competition. Companies learned to design for manufacturability because production costs determined market success. They learned to standardize components because parts commonality reduced complexity and expense. They learned to prioritize reliability because customer satisfaction depended on vehicles that worked consistently. German industry had pursued different objectives. Manufacturing tradition emphasized skilled craftsmanship, producing precisely engineered products. This approach created excellent results for customers who valued quality over cost and could afford premium prices. But it could not scale to meet total war demands for equipment produced in massive quantities by semi-skilled workers. The Jeep embodied American automotive maturity applied to military requirements. Every design choice reflected lessons from civilian industry. The synchronized transmission came from passenger car development. The four-wheel drive system adapted technology proven in agricultural tractors. The simple electrical system used components from truck manufacturing. The result was a vehicle that worked reliably because every element was already mature technology. Kübelwagen development had followed a different path. Porsche designed it specifically as a military vehicle, creating custom solutions for military requirements. This produced a machine well suited to its narrow purpose, but difficult to manufacture in large quantities and challenging to maintain under field conditions. The contrast demonstrated that military vehicle design benefited from civilian automotive experience more than specialized military engineering. American designers who understood how ordinary people used vehicles under everyday stress created better military equipment than German designers who optimized for military specifications without comparable practical experience. General Dwight Eisenhower recognized this when he listed the equipment most vital to Allied success in Europe. He included the Jeep alongside the bulldozer, the 2.5-ton truck, and the C-47 transport aircraft. None of these was a combat weapon. All were utility equipment that enabled operations through reliable logistics support. General George Marshall called the Jeep America's greatest contribution to modern warfare. This assessment from the U.S. Army Chief of Staff reflected understanding that wars were won through industrial capacity and logistics, more than tactical brilliance or technological sophistication. U.S. Army historian Hugh Cole interviewed Wehrmacht generals after their surrender. He reported that German military leaders admired the Jeep more than any other item in the American arsenal, not the heavy bombers that devastated German cities, not the tanks that overwhelmed panzer divisions, not the artillery that dominated battlefields. The simple quarter-ton truck, because it represented the manufacturing philosophy and industrial capacity that had actually won the war. This recognition came too late to change Germany's fate, but it influenced how Germans understood their defeat and approached reconstruction. The lesson was clear. Sophisticated engineering mattered less than reliable mass production. Individual component excellence meant nothing if the complete system failed. Theoretical perfection was inferior to practical effectiveness. Former Wehrmacht officers who had captured and used jeeps during the war remembered these lessons years later. At Afrika Korps reunions during the 1960s and 70s, veterans discussed their wartime experiences. The jeep appeared frequently in these conversations, always with respect and often with admiration. A former reconnaissance officer explained his perspective. "We thought German engineering was superior to anything the Allies could produce. The Kübelwagen seemed proof of our advantage, lightweight, efficient, sophisticated. Then we captured jeeps and realized we had confused sophistication with effectiveness. The American vehicle was simpler but more capable. It went places our vehicles could not go. It kept working. When our vehicles broke down, it represented an approach to engineering we had not understood before the war." Another veteran added, "The worst moment was not losing battles, but realizing we could not win the industrial war. When we saw how many jeeps the Americans produced, we understood that Germany faced an enemy whose factories outmatched our armies. They could replace losses faster than we could inflict them. The jeep proved this every time we encountered one." These reflections captured the fundamental lesson that jeep taught to Wehrmacht personnel who encountered it. Wars in the industrial age were won through production capacity, applied systematically to create material abundance. Technical quality in individual weapons mattered far less than adequate equipment delivered in overwhelming quantities. Germany had entered World War II confident that superior engineering and tactical skill would defeat enemies with larger populations and greater industrial capacity. The jeep, along with Sherman tanks, Liberty ships, and everything else American industry produced, proved this confidence misplaced. By 1976, when the U.S. Army began replacing the jeep with the HMMWV, the original vehicle had served 35 years in military service. Many jeeps remained operational in reserve units and Allied militaries for decades more. This extraordinary service life testified to the soundness of the original design and the quality of American manufacturing. The jeep's influence extended far beyond its military applications. It inspired a global industry of civilian utility vehicles. The commercial Jeep CJ series, introduced in 1945, evolved into the Wrangler still produced today. Land Rover in Britain, Toyota in Japan, and dozens of other manufacturers created similar vehicles influenced by the Jeep's proven concept. German manufacturers eventually produced their own utility vehicles, incorporating lessons from wartime experience. The Volkswagen Type 181, introduced in 1969, resembled the Kübelwagen superficially, but incorporated four-wheel drive and design improvements informed by studying American vehicles. It never achieved commercial success comparable to the Jeep, but demonstrated that German industry had absorbed the relevant lessons. The final verdict on Kübelwagen versus Jeep came from those who used both. Wehrmacht mechanics, officers, and soldiers who had direct experience with German and American vehicles reached consistent conclusions. The Kübelwagen was an excellent vehicle within its design parameters, but the Jeep was the better vehicle for modern mechanized warfare because it prioritized practical effectiveness over engineering elegance. This judgment shaped how post-war Germany approached automotive manufacturing and influenced global vehicle design. The synthesis of German precision with American mass production philosophy created the modern automotive industry, where quality and quantity are both essential rather than contradictory objectives. The story of Wehrmacht officers and the Jeep is ultimately a story about learning through adversity. Pride told German soldiers that their engineering was superior, that quality would triumph over quantity, that sophistication would overcome simplicity. Reality taught them otherwise through 647,000 examples. American vehicles were not better engineered than German equivalents in most technical specifications, but they were better designed for modern warfare's realities, producible in massive quantities, maintainable by minimally trained personnel, built with common interchangeable parts, reliable under abuse. This functionality, multiplied by American manufacturing capacity, created overwhelming material superiority that no amount of German skill or courage could overcome. The Jeep had been more than a vehicle. It had been an education in industrial warfare. Wehrmacht soldiers, humbled by defeat, proved to be attentive students. They studied not just how to operate American equipment, but why that equipment was designed as it was, and what those design choices revealed about manufacturing philosophy. That knowledge, painful in its acquisition, became the foundation for Germany's reconstruction and eventual prosperity. The defeat taught humility. American equipment taught functional engineering. The combination produced a new German philosophy that served the nation far better than pre-war hubris ever could. The final assessment belongs to those who admitted what they learned. We never had vehicles like the Jeep, one former Wehrmacht mechanic stated in 1998 at the final Africa Corps reunion. Not in the numbers, not with the reliability, not designed with the same philosophy. We built for perfection. They built for production. In total war, that made all the difference. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.